In an inter-process communication, we have already seen the introduction part of the message passing system. In previous lectures, we have also discussed a shared memory system, the shared memory region among the processes, and also a message passing system. Now, in this lecture, we will understand the direct and indirect communication method along with the issue which is related with the naming. Now, if a process P and Q wants to communicate, they must send a message to and receive a message from each other. For sharing the information, we must establish a link between P and Q. Then only the P and Q can communicate with each other. They may send the message to and receive the message from each other. For that, a communication link must exist between them. A link can be implemented in variety of ways. So we have a methods to implement a link between P and Q, and also a send and receive operation can be performed between P and Q. So these send and receive operation also we will understand how this will work. Now, in this lecture, we will understand the direct and indirect communication method and also the issue which is related to the naming. Now, let us start with the naming. So, in the naming, processes that wants to communicate must have a way to refer to each other. Means in one or other way, the processes which they wants to communicate must have a way means we have to select the link or the path. So the processes must have the link or path to refer each other. They must, or we can say they can use either the direct or indirect communication. Now, in the direct communication, each process that wants to communicate must explicitly name the recipient and sender. Means uh, we have to explicitly mention who is the receiver and who is the sender. So each process that wants to communicate must explicitly name the recipient also who is going to receive the message, and the sender also who is sending the message in the direct communication. In this method, if the sender sending the message, the sender has to mention to whom it is sending the message. Now the send uh, operation we are performing here. So in the send, a P and message. So P is the receiver who receives the message. So send a message to a process P. So we are sending a message to process P. Similarly, a receive operation also has a sender name explicitly. So Q message. So receiver receives a message from process Q. Now here is the sender is the Q and the receiver is the P. So both the senders and receivers names have been mentioned in these send and receive operation. A communication link in this scheme has the following property. Now the communication link which we have established between the P and Q has some of the properties. Now the first property is a link is established automatically between every pair of process that wants to communicate. So here the P and Q wants to communicate, automatically the link is established between these two pair of processes. Now the processes needs to know only each other identity to communicate. Means the P and Q only, they only know the identity of each other to communicate. So P must know the Q and Q must know the P. So if they know the identity of each other, they may communicate with each other. The second property is a link is associated with explicitly two processes, means this link is established between the two processes explicitly. Between each pair of processes there exists exactly a link, means we have a single link between the two processes. Now what happens in this schema, this exhibit a symmetric in addressing, means this schema exhibit the symmetric in addressing. What is mean by symmetric in addressing? That is, the both the sender process and the receiver process must name the other to communicate, means we are mentioning the names of the receiver and the sender here. Okay, so the P and Q is already mentioned over here, so that these two processes can communicate with each other. So this symmetric means, symmetric in addressing means we are mentioning both the sender process as well as the receiver process name. That is the meaning of symmetric in addressing. Now coming to the next method, that is the another method or the another variant in the direct communication. So here only the sender name the recipient is not required to name the sender, means if you have a send operation, there we are mentioning P and message, that is the send a message to a process P. But if you see this receive operation, in the receive operation we have not mentioned any receiver name, means we have not mentioned here a receiver receiving a message, then we have only ID, we don't have Q here. So Q is the sender, but instead of sender name explicitly writing, we are writing ID, means receive a message from any process. If you write ID, you can receive a message from any ID, okay, from any process. So that ID might be Q, it might be A, it might be C, it might be D. Any processor can send a message and receiver can receive a message from any process. So this is the another variant in direct communication. Now the variable ID, this ID is set to the name of the process with which the communication has taken place. And also there are some disadvantages in both the schemes, symmetric and asymmetric. That is, it is the limited modularity of the resulting the process definition, and also changing the identifier of a process may necessitate examining all other process definition. So what happens in this schema, it will exhibit asymmetry in addressing. Asymmetry in addressing means in receiver there is a ID, we have not mentioned the exact explicit name of the sender. It means that we can receive the message from any process. This is a asymmetry in addressing, that is both the sender process and the receiver process must name the other to communicate, but we are mentioning the ID, but exactly we are not mentioning the name, right? So disadvantages say that it is the limited modularity of resulting the process definition, and also changing the identifiers. So ID means we can write A, we can write B, we can write Q, we can write W, right? So message can be received from any process. So we have not explicitly mentioned a particular process name. Hence, it is a asymmetric in addressing. Now, in indirect communication, this is the second type of communication what we have. So we have just only discussed the direct communication. There we have established a link between a P and Q. But whereas in the indirect communication, the messages are sent to and received from the mailboxes or port. Now the port is acting like an item, right? So between the sending process and receiving process. Now let us understand more detail in these points. A mailbox can be viewed abstractly as an object into which the messages can be placed by the processes and from which the messages can be removed. Means a mailbox can be viewed as an object. Now, this object will receive the messages from the process and also send the messages from the process. Now, a message is sent. Assume that there is a P process sending a message to this object mailbox, and similarly, Q is receiving the message from this mailbox. Now the P is sending to mailbox and Q is receiving from the mailbox. Now this mailbox is an object who is receiving and sending the messages. So each mailbox has a unique identification, means this mailbox is having a unique identification. Now the two processes can communicate only if the process have shared mailbox. Means the meaning of this is if the processes have shared mailbox, means uh, if you have two processes, for example receiving processes P, Q, R, let me take R also. Now R is also receiving a message from mailbox, Q is also receiving a message from a mailbox, right? Only if the process have shared mailbox, means if this object is shareable, then only this can be possible. The two process can receive the message, that is R and Q. Now there is a send a message, send a message to mailbox. Now we have named it as A. So A is a mailbox. Now we are sending a message to a mailbox. Similarly, a receive operation can be performed, and in the receive also we have written A comma message. Now receive a message from a mailbox A. This is how we can use this indirect communication where the mailbox or the port is used. So the port is the end point of network or end point of receiving node. Okay, now here a communication will have some of the following properties, like a link is established between a pair of processes only if both the member of the pair have shared a mailbox. A link may be associated with more than two processes, and between each pair of communicating process a number of different link may exist, with each link corresponding to one mailbox. So we have just seen here, and in the next slide also we will understand how this will work, what are the properties which we are discussing here, how it will establish a link between a pair of processes if both the members of the pair have a shared mailbox, and also a link may be associated with more than two processes. Now here take the example of P1, P2, P3. all share a mailbox A, the mailbox A, right? The name of the mailbox is A. Now we have three processes P1, P2, P3, right? Now process P1 sends a message to mailbox. Now it is sending the message to mailbox. While both P2 and P3 execute a receive from a mailbox, means these will receive a message from a mailbox. Now which process will receive the message sent by P1? Now the question is, if one process which P1 is sending a message to mailbox A, now who will receive that message? P2 or P3 or both? So this answer is depend on which of the following method which we choose, right? So again, let's have the some of the methods which we choose to resolve this problem, right? So if the message is sent by P1, either P2 or P3 will receive or both will receive. So we will having some methods by which we can answer this question, right? A first method is allow a link to associated with two processes at most, means we can establish a link between the two processes at most, means we can establish a link between P1 and P2 or P1 and P3. This is the first solution. This is the first method to answer this question. A second point says that allow at most one process at a time to execute receive operation. Now the both the P2 and P3 is having a receive. So these execute a receive from A. Now we have to uh, allow now we have to allow at most one process at a time to execute receive operation. It means that we have to give the receive operation to either P2 or P3. Not both cannot execute at a time. One can execute the receive operation. So we in this way also we can resolve it. Either P2 can receive a receive operation or P3. The third method is allow the system to select arbitrarily which process will receive the message, that is either P2 or P3, but not both will receive the message. The system may define an algorithm for selecting the process will receive the message. For example, we may have the algorithm like round robin where the process take turn receiving the message. The system may identify the receiver to the sender. Now what happens in this third method, either one of the process will receive the message from P1. It's depend on the system. Let the system will choose, right? So let the system will choose or select which process will receive the message, either P2 or P3. Not both will receive the message. So the system, for that the system will define an algorithm for selecting the process. So like round robin, first come first serve, right? So these are the CPU scheduling. So we will discuss in the next chapter in upcoming videos. So we can choose one of the algorithm. Based on that algorithm, the one of the process will receive the message. So this may identify the receiver to the sender. So in this way we can resolve the problem, or we can give the answer to this question, which process will receive the message sent by P1. Okay. Now the mailbox may be owned either by process or by the operating system. Now, if we are talking about the mailbox, it may be owned by either process or operating system. So if it is owned by the process, it can be created, it can be terminated. Means mailbox can be created or it can be terminated. But if the mailbox is owned by the operating system, right, if it is owned by the operating system, now the operating system responsibility to hold this mailbox, and it will be having a different characteristics from the process if it is owned by the operating system. When it is owned by the process, when the process terminates, our mailbox is also gets terminated or deleted, right? So this is all about this direct and indirect communication and the issue which is related to the naming. Hope you understood the direct communication and indirect communication. So we have two methods, and also we had discussed about the naming issue in this lecture. So thank you for watching.